Hi, everybody. Thanks for joining me again. We're going to work on two-step equations today. We are just going to focus on the seventh grade standard aspect of this. My advanced class, we might start going a little bit deeper into it as we kind of overlap with the eighth grade standards. But for now, we're just focusing on like the basics of the basics. So two-step equations are called that because guess what? It takes 2 steps to solve them, right? When you solve equations, we've talked about this before a long time ago at the beginning of the year, you use inverse, which means opposite operations. You want to work backwards. You're trying to figure out what you had before you added 5 or before you divided by 3 or whatever the case is. Since you're working backwards, you also need to go in the opposite order of the order of operations. So usually you'd be multiplying and dividing before you add or subtract, but we're going like top down this time. So we're going to add or subtract before we multiply or divide. That's not true for every single type of problem, and I will later show you the exception to that, but for most of them, that's how it's going to work. You want to make sure you focus on the variable. Don't always focus with moving what's on the left side or the right side. It's all about where your variable is. So if I can get this to turn, let me show you a few. Here's what I would suggest. Suggestion number 1, draw a vertical line through your equal sign. That way, as I'm talking about left side and right side, you can visualize better what that means. I'm not talking about left and right of my variable. I'm talking about left and right of my equal sign. So the next thing we want to do is figure out which side is our focus. So do you remember what we look for? You look for the variable. Here's my variable on the left side, right? I see an X. I'm going to put a box around that whole term, that whole 3X term. That's just kind of my reminder that the 3 sticks with the X until the very end. They're best friends, they're buddies, and they can't be separated until that very last step. So the first thing I need to do is get rid of what's with the variable, but not in that box. So I want to get rid of the plus 4. The inverse of adding 4 is subtracting 4. It's about inverse operation, not just inverse numbers. So I'm going to subtract 4 from the left. But an equation's like a teeter-totter, and you've got to keep it balanced. You don't want to make somebody go flying up in the air or thumping down on the ground. So if I take 4 away from the left, I'm also going to take 4 away from the right. Don't tip your teeter-totter. And now I'm going to go straight down in all my columns. When you're solving equations, if you don't always go straight down, it's not the end of the world. But I always get in that habit. That way, when we get into inequalities and it does ruin everything, if you flip-flop sides, you're not making that mistake. So we're just going to go straight down in all of our columns. I still have a 3X. I haven't touched that yet. Plus 4 minus 4, it's like it never even happened. If I give you $4 and then I take it back away, I'm a jerk, but we break even, right? It's like it never happened. I'm going to bring down my equal sign, still on that line that I drew. On the right side, we've got to think back to our operations with integers. Negative 11 minus 4. That's like having a negative 11 and a negative 4. I owe one person $11. I owe another person $4. So altogether, I owe 15. So that's a negative 15. Now go back to your variable because you're not quite done. I know what 3x equals. I want to know what 1x or just x is. When the number's right beside the variable, it means multiply. The inverse or opposite of multiplying is dividing. So I'm going to divide that by 3. And again, you've got to keep your teeter-totter level. So I'm going to divide the right side by 3. And then straight down my columns. Times 3 divided by 3. If I bring my groups together and then I separate them back out, it's like it never happened. So I just have an x, or 1x is the same because 3 divided by 3 is 1. Bring down my equal sign. Negative 15 divided by 3 is a negative 5. So I think my answer is negative 5. I would encourage you to always check before you circle it and call it done. So if I go back up to my original problem, instead of saying 3 times x, I'm going to say 3 times negative 5 because that's what I think my answer is. Plus 4 equals negative 11. So I rewrote that original equation. I just pulled out the x and I put in what I think the answer is. So then work this out, evaluate it. 3 times negative 5 is negative 15. Plus 4 equals negative 11. That's a true statement, so I know my answer's good. Let's do another one. This time the variable's on the other side, but we're still going to treat it the same. So I'm going to split it through the equal sign. I'm going to locate my variable, and I'm going to box the variable term because I can't touch him yet. I need to get rid of that minus 8. The opposite of subtracting 8 is adding 8. And if I do that on the right, I need to do that on the left. And then I'm going to go straight down my column. 0 plus 8 is 8. Bring down my equal sign. Bring down my negative 2x. And then minus 8 plus 8, they cancel. It's like it never even happened. That was the whole idea. Find your variable again. With the variable, I've got a negative 2 touching it. That means multiply. The opposite of multiplying is dividing. So to undo that, I need to divide both sides by negative 2. Straight down your columns again. 8 divided by negative 2 is negative 4. Excuse me. Bring down your equals. On the right, negative 2, the times and divide, they cancel. So I just have my x. I think my answer is negative 4. But before I circle it and call it done, I'm going to rewrite my problem. 0 equals, instead of negative 2 times x, I'm going to say negative 2 times negative 4. And then minus 8. So that says 0 equals, that becomes 8 minus 8. That's true. So I know my negative 4 is good. Let's do some more. Now this one doesn't look like a two-step equation, but it really is. I'm going to go ahead and I'm going to separate it. The x isn't by itself. I don't see a number, but when you don't see one, it means you have one of them, right? Just saying I have an x really means I have one x. So if I say negative x, it really means negative 1x. If you want to go ahead and write that so you can see it, that is fine. So focus on the side that has your variable. I'm going to box in that term. That means I need to get rid of the 8 because that's with the variable but not in the box. The opposite of adding is subtracting, so I'm going to subtract 8 from both sides. Straight down your columns. I still have negative 1x. Plus 8 minus 8, it's like they never even happened. Bring down your equals. A negative 9 and a negative 8. If I owe $9 and I owe 8 more, altogether I owe $17. Back to my variable. The opposite of multiplying by negative 1 is dividing by negative 1. Remember, it's opposite operations, not opposite numbers. So I'm not wanting to add 1, I'm wanting to divide. Then I also need to divide the negative 17 by negative 1. They cancel over here on the left, and I just get an x. On the right, negative 17 divided by negative 1 becomes a positive 17. Let's check and make sure we're happy with that before we say for sure. So negative, instead of x, I'm going to write 17 plus 8 equals negative 9. I agree with that, so we're good. Let's do another one like that. Separate through the equal sign. I don't see a number with my x, which means there's really a 1. Now, I know this one's in a different order, but that minus is really a negative. So it's not just a 1x that I'm going to box. It's a negative 1x. What I need to get rid of is that 7. Right now, it's just a positive 7 hanging out there. So to get rid of it, I need to subtract it from both sides. So on the left, I still have negative 1x. On the right, 10 minus 7 is 3. Back to my variable, I've got a negative 1 attaching it, so I'm going to divide both sides by negative 1. And I think my answer is x equals negative 3. Let's find out. I'm going to go back up to my original problem, but instead of writing x, I'm going to plug in negative 3. Now check this out though, it wasn't just minus 3, it was minus negative 3. In the real world, that would be in parentheses. And then look, we have a face problem. Remember those? When you have a face, you replace with a plus. So that really says 7 plus 3 equals 10, which is good. My answer must be negative 3. These look totally freaky, but we know that a fraction bar really just means divide. Every fraction is actually just a division problem. So I'm going to go ahead like before. I'm going to separate through the equal sign. I'm going to put a box around my variable term because he's going to wait with the variable until the end. So what I need to do is get rid of that add 6. The opposite of plus 6 is minus 6. And I'm going to do that on both sides. And then I'm going to go straight down my columns. So on the left, I still have x over 4 plus 6 minus 6. It's like it never happens. Equals 2 minus 6. If I have $2 but I owe 6, then I'm in the whole 4. So that would be a negative 4. Now back to my variable. That fraction bar means divide. The inverse of dividing, I am choking on air today, guys. The inverse of dividing is multiplying. So I'm going to multiply both sides by 4. It cancels over here and just gives me an x. And on the right, negative 4 times 4 would be a negative 16. Let's check it, make sure we're happy with it. So my original problem, instead of writing x, I'm going to plug in what I think is my answer, negative 16 over 4 plus 6 equals 2. Let's see, negative 16 divided by 4 is negative 4. Negative 4 plus 6, that is indeed a positive 2. We're good. Let's try another one of those. And I'm going to have you guys do some soon. I'm going to split this through the equal sign. My variable's on the right this time, so that's the side that I'm focusing on. I'm going to box in the variable. With the variable, I have a minus 5. The opposite of subtracting is adding, so I'm going to add 5 to both sides. Now straight down your columns. On the left, negative 15 plus 5. If I owe 15 and I have 5, that means I'm in the whole 10. So that's a negative 10 equals, I still have x over 3. Negative 5 plus 5, they cancel. They're gone. Back to my variable part on the right side. I see divided by 3. The opposite of dividing is multiplying. So I'm going to multiply both sides by 3. 3 times negative 10 is negative 30 equals, divided by 3 times 3, it's like it never even happened. If I separate them into groups and then bring them back together, it's like it didn't even exist. So that's just my x. I think my answer is negative 30. Let's go back to the original problem and plug that in and see if it makes sense. So that would say negative 15 equals, instead of x, we're going to plug in negative 30 over 3 minus 5. So that would say negative 15 equals negative 10 minus 5. Yep, I'm good with that. Negative 30 is the answer. Okay, when you've got your fraction, but the minus sign is with the x. So basically, it looks like it's just in a different order, right? I'm still going to separate like I was. I'm still going to box the variable part. But like we did a couple pages back, that minus sign is also like a negative. It's going to stay with it. And I'll show you how we're going to simplify that in just a little bit. Right now, though, let's focus on the other number. To get rid of that 1, I'm going to subtract it from both sides. So on the left, right now, I have x over 2, and the whole thing is negative, right? Equals negative 5. Now, when you have a fraction, one negative makes the whole thing negative. It doesn't matter if it's on the top or on the bottom or just out to the side. So I said I'd show you how I simplify it. This is what I do. I rewrite this as x over negative 2. It's the same problem. It's just looking at it a different way. But now I know I'm dividing by negative 2, and the opposite would be multiplying by negative 2. So that's how we're going to cancel out that sign. So now on the left, I have an x. And on the right, that becomes a positive 10. Let's make sure that's good. If I plug that in, it would say 1 minus, read the problem, Luger. 1 minus 10 over 2 equals negative 4. That means 1 minus 5 equals negative 4. Yep, sure does. Let's do one more of those, and then I have to show you the exception to that adding and subtracting first rule, and then I'm going to have a page where you're going to try some, hopefully. I'm going to split these. I'm going to box the variable part, but remember that negative sign goes with it. To get rid of the 2, that's just a normal positive 2, so I'm going to subtract him out of there. And now I'm going to go straight down. On the left, 3 minus 2 is 1 equals 2 minus 2. It's like it's nothing. It went away. And now here's where I'm going to just adjust where that negative is. I'm going to make it say x over negative 5. That way the negative's attached to the number and it's way easier. The opposite of dividing by negative 5 is multiplying by negative 5. I'm going to do that on both sides. So on the left now I have negative 5 equals, that cancels, and I just have my x. Let's plug it in and double check. That would say 3 equals 2 minus negative 5 over 5. So that would say 3 equals 2 minus negative 1. Minus a minus, that's really a face problem. When you see a face, replace with a plus. 3 equals 2 plus 1. Yes, indeed it does. Okay, last type of problem. This is the exception to the rule where you add or subtract before you multiply or divide. The problem with these is that addition and subtraction is trapped within a fraction itself. But remember, a fraction bar just means divide. So what I want to do is get that x minus 1 out of the fraction. I'm going to multiply both sides by that bottom 6. So that cancels. And now I just have the x minus 1 on top. On the right, that would be a 35. Now it's a one-step equation. The opposite of subtracting 1 is adding 1, because you want to know what happened before you took 1 away. So you put it back in, and you find out that x equals 36. Let's just talk through this one to check it. If I do 36 minus 1, I get, what did I do? Oh, I know what I did. Look, do you see? See, this is why we check things, because when I plugged in, I was like, wait a minute, 36 minus 1 is 35. That's not right. Why in the heck did I say 6 times 6 is 35? You guys, am I tired? Am I going stupid? Got to trust the math teacher to multiply, right? What in the world? I bet I said 36 and I just didn't even write it. Who knows? Okay, so you can laugh at my stupidity for a minute, and now we're going to move on. So I have x minus 1 equals 36, add 1, that should be 37, right? So then plug it in. That's why you check it, because how many of us make silly little mistakes like that, just going too fast? Like, brain goes faster than the hand does. So 37 minus 1 is 36. 36 divided by 6 is 6. So now that I found my stupid mistake, wow, good job. Yes, I know that works. Just proves that nobody's perfect, even though I'm pretty darn close. Don't laugh at that. So on the right, I need to get it out of that fraction bar, right? So the opposite of dividing by 4 is multiplying by 4. I promise you, I'm going to say and write the right numbers from now on. I don't know why I just had that total mental block there. Okay, so 4 times negative 1 is negative 4 equals. It cancels over here like it never even happened. And I just have x plus 3. See, now I'm all paranoid and I'm quickly double checking every single thing I say and write. So my variable's on the right. It's a one-step equation because there's nothing attached to the x. The opposite of adding 3 is subtracting 3. I'm going to do that on both sides. On the left, if I owe 4 and I owe 3 altogether, I owe 7. And on the right, plus 3 minus 3, it's like it never even happened, and I just have an x. Let's double check. So over here on the right, that would be negative 7 plus 3. That's negative 4. Negative 4 divided by 4. Yep, negative 1. Oh, man, I'm so mad at myself for doing that. Okay, so here are 4 problems, kind of one of each of the types that I've shown you. I would really encourage you to hit pause on your video and give these a try. And then when you play back, let's see if we match on our answers. I promise I'll be careful and I won't do anything dumb, in theory. All right, hopefully you did that. Let's see how you did. I'm going to separate through the equal sign. I'm going to focus on the left because that's where the variable is. I'm going to box that as a reminder to myself that 8's going to stay attached until the end. The opposite of adding 6 is subtracting 6. And now I'm going to go straight down. On the left, I still have 8x plus 6 minus 6. Bye-bye. Bring down my equals. Negative 10 and negative 6, that's a negative 16. On the left now, that means times 8, and the opposite of multiplying is dividing. If I divide on the left, I divide on the right because I'm not tipping that teeter-totter. So I end up with x equals -2. And if you plug it back in, you will find that is, in fact, the correct answer. Let's do the next one. I'm going to separate through the equal sign. Now, when I box my variable, really that has a -1 attached to it. To get rid of that -3, I need to add it back in, and I need to do that to both sides. So that gives me 15 equals -1x. The opposite of multiplying by -1 is dividing by -1. So I end up with -15 equals x. How are you doing so far? If you feel like you're missing these and you're not sure why, there's no shame in going back and rewatching parts of the video and trying again. Number 3, I'm going to separate. I'm going to box. The opposite of adding 4 is subtracting 4. I'm focusing on that because it's with the variable but not in the box. 0 minus 4 is -4. I still have x over 5. Plus 4 minus 4, they go away. Opposite of dividing by 5 is multiplying by 5. So then I end up with -20 equals x. Okay, one more. I'm going to separate through my equal sign. Maybe. But the issue is that x is trapped within a problem within a problem. So I'm going to cancel out that fraction by canceling out the division. I'm going to multiply both sides by 3. So then on the left, I'm just left with that thing on top. The x minus 11 equals -3. Now the opposite of subtracting 11 is adding 11. So I'm going to do that to both sides. And I end up with x equals, let's see, if I owe $3 and I have 11, I could pay my bill and have 8 left over. So a +8. That's the end of this lesson. Sorry about the idiot mistake I made, but we all do it, right? It's fine. At least I caught it. But thanks for sticking it through. I hope you were able to learn something from this and get some practice. My students, we will continue practicing these in class. They will show up for years to come in your math class, and you'll just keep building and expanding on these same principles here. So let me know if I can help you with anything else, but thanks so much for watching till the end. Bye.